Hello, everybody. Welcome to the asynchronous lecture on JavaScript. So what we're going to learn about today is what is asynchronous programming? What are we going to do with asynchronous programming? Why are we using it? And what are great best practices when dealing with asynchronous programming? We're going to talk about everything you need to know in order to implement asynchronous programming in your code. But first, let's talk about what asynchronous programming is. So I'm going to go ahead and share my screen and we will take a look. So asynchronous programming, you might check out some websites, like for example, let's take a look at stock twits. Notice how some parts of the page loaded up quicker than the others, and the parts that could loaded up, right? So right now it's all cached in my browser. So maybe if I go to a different, in the incognito window where the cache is removed, the browser cache, it will have to regather all this data from scratch. Let's take a look. We can go slow motion format. So you see, notice how, and this ad loaded up last, right? So certain things in this website loaded up immediately, and other things took a while to load. But could you imagine if nothing loaded until the slowest thing finished loading? And if I refresh this, let's see, what is the slowest thing that's loading? Probably like this chart right here or this video. And let's say this web page is getting this video and this chart from some external resource. So maybe that's probably why it takes a little bit longer for this video and this chart to show up, because it's coming from another resource that they might be relying on. However, the web page decides to load up all the other content even before this content finishes loading up, which is good because at least it keeps me busy. I can actually look at some other things going on. And then the chart comes up and I'm like, okay, cool. There's a chart. Let's take a look at the Google price. Okay, stock market went up. All right. You trying to tell me the stock market went up? Should I put my money in there? I don't know. This is not financial advice. This is coding advice. So I don't know, but that's a good company. But yeah, notice how some things load up faster than others. And it's good that our web page here isn't waiting for the chart to load up before it loads up any other content. That's asynchronous programming in what you're seeing right now. Synchronous programming would be if like this whole page would wait for everything to load up. So it'll go in the order that it's written, the code. So maybe it loads up this part, this part, this part, and this part. Whatever parts it's written, it's going to load up those parts in that order. But some things might actually take longer to load than other parts. So our web page wouldn't load anything else until the next thing is fully loaded, or the previous thing is fully loaded, like this chart. And then maybe it'll have to load up this, and maybe it'll have to load up this. But asynchronous programming is where all this stuff loads up, whatever it can, and anything that's slow to load up, it'll take its time to load up. But our app is not waiting for that thing that's slow to load up before it can display any other piece of information. So that's asynchronous programming. So let's take a look at how we can implement asynchronous programming in our own code. So what we can do here is, let's get rid of the incognito window. Let's take a look at this application that I have built for us. All right, so this is the web page. It just says asynchronous JavaScript, and there's 3 boxes here, and we're actually going to fill in more information for these other 2 boxes. But for now, our application, I want to show you synchronous programming, which is just code running in the order that it's written in. So let's take a look at synchronous programming. And in this particular page, there is nothing asynchronous going on except for this word saying asynchronous. So it's just code that's being written and it's being executed in the order that it's written. So let's take a look at the code and see what I'm talking about. So first and foremost, we have this HTML page where the web page is, right? So that's just going to be some HTML page. Don't worry too much about what the HTML code is doing right now. Just know that this is HTML and it is used to display content on the web page. This is not a lecture on HTML or CSS, but I also use CSS to style the HTML so that it looks pretty. Well, so it doesn't look absolutely disgusting. How about that? It still doesn't look too pretty, but at least there's some styling. So that's what the CSS file is used for. So don't worry too much about this code. We'll have probably another video where we talk about HTML and CSS from scratch. Actually, I have one. So please take a look at the introduction to web development video that I have. I forgot what I called it, but okay. So let's go on to the next file. The next file is this main.js. This is our JavaScript. This is where most of our coding is going to happen. And here we have an array of greetings. So these are some common greetings that I can see myself using when I want to greet people. Here's an array of, different phrases. These are some phrases that I commonly use. So I just decided to put them here. And then here's an array full of some goodbyes. And here are the common goodbyes that I usually use. So I like to say, all right now. All right, you take care now. All right now. All right, one time. All right, peace out. All right, bye. All right, see you. Adios. Right? These are the goodbyes that I like to use. So these are some pieces of information, and I wanted these pieces of information to show up on this web page. So here's the web page, and the greetings show up here. In this box, it won't show all of the random fortunes. It'll actually just pick one random one each time I refresh, and it'll show it. So it'll give us a random one of these. Let's take a look at that. Stay humble though, you got this, right? You can even ask it a question like, hey, are you gonna hit the like and subscribe button? Yep, you out ya. All right, so I'm glad that the fortune teller is working perfectly for me right now. That's great. And then we also have the goodbyes column, and this one just shows all the goodbyes from this array. Cool. And that's what our code here is currently doing. Don't worry too much about these 3 lines of code. What they're just basically doing is these 3 lines of code are selecting elements on our HTML file so that we can put content in those HTML locations. So what do I mean by that? This document is how you can gather something from the HTML, document.querySelector, and I can tell it which class or ID I want to gather, and it will let me, select this class or this class or this class. And in this div, if I want to add new content, I need to actually be able to select this div and add things to this div. And that's what I'm doing here. Here it is going through the greetings array. So for each of the greetings, the word greeting represents each one of these words. For each of those greetings, we are going to create a LI tag. So in HTML, an LI tag looks like this. So you might have an ordered list, OL, and then LI, and then you'll say, hello, hi, right? And in that case, it will create something like this. If you have an OL, if you have just these two I just manually created just now. If you have a UL, that will create an unordered list where it will look like this with bullets. Okay, cool. So that's what UL-LIs do. So first I would need to create a UL and then add LIs to it. And I wanted to add an LI containing each greeting from the array. So we just did it in a quick way using a for loop, because here I have an array of greetings already. So I just loop through that array, and then for each greeting, create an LI tag. An LI tag is just like a bullet, kind of like this. So we'll create a bullet with the actual greeting for each greeting. So that's how we're going to have a bullet for each greeting. And then we're going to put that in the greetings column. So to the greetings column, we're going to add the LI. Matter of fact, we should probably add the OL, but that's okay. You know what? This code is a little bit wrong. I'm creating an OL tag, right? I want to create an OL tag, for example, OL. and then have LIs inside of the OL. So what I would do here is actually put the OL dot append child, and then so now the OL is going to have a bunch of LIs. It's going to have an LI for each greeting, and then it's going to after the for loop is done, we're going to put it in the greetings column. So greetings column dot append child. This is how you tell it to add some HTML to it, and I'll tell it which HTML. I want to put the ordered list of greetings, OL. So OL just means this OL elements. It'll look something like this. I'll show you guys what it looks like. So it's a bunch of numbers. And if I click on the elements, you'll see that in the div column, in the first row, in the left div, you'll have an ordered list, and you have an LI element for each greeting. So that's what we generally basically did. So that's the gist of what I have built so far before we talk about synchronous and asynchronous JavaScript. I just wanted to catch you up to speed. So it creates an OL tag, and for each item in the greetings array, it's going to create an LI tag and add the LI to the OL, and it's going to add the OL to this div called greetings. This div is just this box right here. Okay, cool. And for the random fortune one, it just what that does is it just gets a random fortune and creates a H3 tag and gets a random fortune from the fortune array. Don't worry too much about what this code is doing. Just know that it's getting me a random value from this array. And we're putting a random value into the H3 tag or H4. Maybe I could call this the H4 tag. H4 tag. And that H4 tag is going to be added to the middle column. So what that's going to look like is it's going to get a random in the middle column. If I go to the first row in the middle column, there's a H4 tag with a random message. Right? Stay humble though. And the goodbyes work very similar to the greetings, except it's an unordered list, meaning there's bullets instead of numbers. So that's basically all the main thing that's going on here. And this code is synchronous, meaning I have these three functions defined. And if I call these three functions, the program is going to run in the order that I call these functions. For example, right now I have greets first, and then random fortune middle, and then say bye. So it's going to give me the greet information first, and then it's going to populate the random fortune, and then it's going to populate the goodbyes last. So if I refresh this page, you'll actually see that. And to the human eye, we actually don't see this in slow motion because it happens so quick. Matter of fact, it looks like all of it loaded up at the same time, but we can actually prove that it loaded up in the order of greetings, random fortune, and goodbyes by looking at the console, and we'll see the in greetings, in random fortune, and in say bye function logs. Because I have console.logs at the beginning of each of these functions. So when these functions run, it'll console.log something. So we will know that these functions ran, when these functions ran by looking at the console.log. So we'll see the order is greet, random, and say bye. Greet, random, and say bye. Now, check this out. I'm actually going to split screen here so that we can have a closer look here. So if I were to move this, up in this order, you'll see that the code runs in the order that is written. Random fortune, say bye, and greeting, right? So it's written in this order to execute these functions in these order right here. And that's the order that we see. This is synchronous programming, where code runs in the order that it's written in. So let's talk about asynchronous programming, because there's going to be many times in your code and in your application where you might rely on some tool that could take an unknown amount of time to fully finish executing. And you might want to wait for that particular process to finish before you run the next line of code. In that case, you will have a function that you're waiting on. So maybe you want other things to happen while you're waiting for that function. For example, I can make it seem like the greet function takes a little bit longer to run. Let's say we're actually getting a bunch of greetings from some API. An API is just another resource that your computer can access. And usually you can make API calls to external resources in the World Wide Web. So it would have to make a network request and go through the internet and get some data and come back to you with that data. And that will take longer than just code that is already written on your computer to show up. So in that case, some code might take a little bit longer to finish executing. So let's make it seem like the greet function actually takes longer to work by using something to emulate an API call as if it takes a little bit longer. We can use something called sets timeout in JavaScript, and you'll give it an arrow function and then a number of milliseconds. Let's say 2,000 milliseconds. That's basically 2 seconds. So if I press enter and I put all this code in here, let's see, notice what happens. Greetings takes a little bit longer to run. Notice my code is asynchronous, which is good in a way, because there is some pieces of content that's already loading up, and it's not waiting for all this content to load up first before it loads up the other pieces of content. Even though if right now the order actually makes it seem like greetings should be last, right? But what if greetings, the greet function is being called first? Well, it's still not running in the order that it's being executed, is it? Greet is called first, and then the fortune, and then the say goodbye. But if I refresh this page, you'll actually see that the fortune and goodbye show up before the greetings, because greetings takes a little bit longer to run and fully execute, because it takes 2 seconds longer. This 2000 means 2000 milliseconds, so 2 seconds longer for all this code to run in the set timeout. Okay, so that's good in one hand, where we can see that our application doesn't lag waiting for the greetings to show up before it can do these other lines of code, right? So even though greet is called first, these other functions will still run and execute, and it's not going to be waiting for greetings to finish loading. And then greetings finishes loading up whenever it can. So our application is efficient because it can still do other work while we're waiting for some asynchronous data to come back. Or when I say asynchronous, meaning some process where we don't know how long it'll take to execute. In this case, we know exactly how long it'll take to execute because we're emulating an asynchronous process right now by forcing it to take longer than it needs to execute using set timeout. But this is not always going to be the case. Sometimes you'll just have an API call. Maybe you'll make an API call, which we're going to do an example of later, where the response will take an unknown amount of time. We won't know that it'll be 2000 milliseconds. It could be 1 millisecond. It could be 1000 milliseconds. It could be 1 million milliseconds. We don't know that. We don't know how long it's going to take, but we might want our application to do other processes without having to wait for that particular process that would take an unknown amount of time for, right? So that's the good thing about asynchronous programming, is we can do that. We can have other pieces of code run while some slower pieces of code can load up. Okay. Just like this. But what if I actually didn't want them to see a random fortune or a goodbye message until they saw all the greetings? What if I wanted to force some order in my asynchronous code? Because right now I have asynchronous code here, the set timeout, and then I have synchronous code, and it goes in this order, but the greet will take longer. So random fortune and say goodbye load up before the greet. But there might be situations where I would want random fortune middle to only be called after greet is finished loading up, and then say goodbye to only show up after the fortune is being displayed. If that's the case, then what originally developers used in order to have that flow in their code is they used something called callbacks. So what I can do is, here's the greet function. I can pass in a callback. A callback is just a function that you pass in as an argument to another function. So I'm just gonna call this callback. So this greet function is going to accept a function as an input. And what I'm gonna do is I'm gonna tell the greet function, hey, here's a function as an input. And in this function, it's going to run the get random fortune. So the get random fortune will only run once greet is called, and greet is going to be called with this. You see this highlighted part? This highlighted part is basically just, if I actually get rid of this line of code, it'll be easier to see. Here's an arrow function I'm passing as an input to the greet function. So this callback represents this arrow function right here. And inside of this arrow function, I'm telling it to call get random fortune middle. So this callback function, if I were to execute it, it's going to call the random fortune middle function. So what I can do is, inside of this code, I can tell it to run callback, and callback here represents the this function right here. And when I call this function, it's going to call the random fortune middle function. So, okay, so it'll do that. So now we can actually see greetings happens, and then the random fortune happens. You see that? Greetings, it waits for the greetings to show up, and then the random fortune shows up. Consult with your pet. One more time. One time for the one time. Boom, boom, right? Cool, so we were able to make it flow. We were able to make it so that the random fortune, even though the random fortune takes less time to load up than the greetings, we were able to make it so that random fortune waited for the greetings to show up, because maybe I wanted them to only see the random fortune after they were greeted. And maybe I only want them to see a goodbye message after they see the random fortune. So then I can also further make it so that the order comes in waiting for this response to finish, and then for this to finish. I can tell random fortune middle, the function here, that it's going to accept the callback. And when I call random fortune middle here, I can pass in a callback function. And in this callback function, I can tell it to run the say by. Now you're probably thinking, this is really confusing now. What's going on? Right? And this is called callback hell. Yeah, that's right. It's called callback hell. I just said a bad word. So, my bad. But here it is. Say goodbye is going to be called, and that's going to be this callback. So if I were to call back here, so now you'll see that greetings happens, and then random fortune happens, and then goodbyes. And maybe the goodbye, maybe the goodbye in the random fortune middle, maybe they also take some amount of time. So let's do set timeout on them. Set timeout. And let's do 1000 milliseconds for this one. And then set timeout. Let me just copy this line. And then copy this line. Format my code. And let's say this one takes another 1000 seconds. So now let's take a look at our code, what it does. Greetings happens, random fortune, and then goodbyes. So what's happening here now is the greet function is going to be called, and we're passing in this highlighted part as our callback to greet. So it's receiving a function, and that function, when it's called, it's going to, right, this is the callback. When it's called, it's going to run the random fortune middle function. So then random fortune middle function runs, and that's going to take another 1000 seconds, or 1000 milliseconds, which is 1 second. So you'll see this happening 1, 2, right? And then 1, and then another 1 second, right? Because the first one takes 2000 milliseconds, so 2 seconds, and then 1 second, and then 1 second. So now going one after the other. Cool. So now we can actually make our asynchronous code flow in a certain order if we wanted to flow in a certain order. Because if we didn't do this, what we had originally was we had greet, random fortune middle, and then say bye. If we wrote it in this order, even though I wanted to run in this order, it didn't run in that order, did it? Because greetings just takes a little bit longer. Maybe some API calls just take a little bit longer than other API calls. And that's going to happen in programming. So writing it in this order doesn't work. You're going to have to do something like this over here if you want it to flow in that order. But this is hard to read. This is called callback hell, where you keep having to pass callbacks and you lose track of what function is doing what. So this is called callback hell. So another way to write this is to use, so what's the solution to callback hell? That's the problem right now. The problem is when we have asynchronous code and we want it to run in a certain order, waiting for some data to finish before running another process, we have to right now use callbacks to accomplish that just like we're doing right now. But this is not fun, because what if we have like 20 other things that need to happen, and this starts to get really nested and really hard to read. So the solution to this is called a promise. A promise allows you to write code that you can allow your asynchronous code to be synchronous and write in a certain flow in the order that you're writing it in by using a promise as well. So let's take a look at that. Right here, we're also making asynchronous code flow in a more synchronous way, but it's using all these nested callbacks, which is hard to read, right? So, but we do get greet and then random and then bye in that order if we write it like this. So we do solve that problem, but it's just really hard to read. So let's find a better solution. A better solution is instead of using the callbacks, so let's just get rid of the callbacks. Let's get rid of the callback. No more callback out. Ain't no callback, girl. Ain't no callback. Few times I've been nesting my divs. Few times I've been nesting my functions. Ain't no callback, girl. Right, we're getting rid of the callbacks. No more callback. So what we're gonna do is actually we're gonna wrap this inside something called promise. So new promise. And in this promise, we're going to have a callback function. I know I just said no more callbacks, but there's a callback. But okay, so we're gonna have a function that's gonna have two parameters, resolve and reject. And what we can do is we can tell it to do all this. And maybe resolve some message saying completed task, completed adding greetings. Okay, cool. So we can return a promise where it will, now what is a promise? Well, a promise allows us to chain our function so that we can write it synchronously, even though there's asynchronous code, like the set timeout. So what I can do is, check this out. Now I can actually say, so this was callback hell. This was the function being written in synchronous, well, us trying to write it in the order that we wanted it, but it not working because it's asynchronous. And this is us forcing it to run in the order that we wanted it to, but using callbacks, using this callback hell. But here's the way with promises. So if I call greet, greet is going to return back a promise. So if it returns back a promise, what I can do is I can do .then on a promise, meaning after the greet is finished resolving, then what I can do is I can run this function inside of the .then. which is going to be random fortune middle. Okay, and now it's going to do greetings and then random fortune middle. Okay, so it did not, it says cannot read properties of undefined reading dot then. So greet is going to return a new promise. Why is this not working? Okay. Return new promise, and it's going to do all this. I could probably have all this code outside of the promise. Okay. Why is this not working? Return new promise. Okay, so dot then, greet dot then. So console.log. What does greet return? Does it looks like it's not thinking that I'm returning a promise. It says undefined. Okay. There's something I'm missing. So let's take a look at what we have here. Okay. Promise resolve and then set timeout. Okay, so I would actually need the new promise over here. And then I would have resolve, reject, and then I'm going to have all this code over here, and I'm not going to have this new promise over here. And it's going to resolve some message here. Complete the greetings. Okay, cool. So that should work. Let's take a look here. Cool. So we have a promise, right? And then once the promise, once it's done, then we're going to tell it to run. So once the greet function completes, we can tell it dot then to run random fortune middle. Now check this out. Now it's going to go in the order that I'm writing it in. You see, greetings and then stay humble. So this is our solution to the callback help, because now I don't have to have these nested promises. Notice how just with 3 functions, it goes nested in 3 layers. Here, I can just keep it to 2 layers, no matter how many functions I need. With the callback help, if I had 20 functions that needed to rely on one another, then you're going to have 20 different layers of nesting. With this way, you're always going to be able to do it with just 1 layer of nesting. Just there's going to be a dot then, and then so if I want to do dot then after random fortune middle, I can actually tell it to also return a promise. Return new promise. Oops, promise. So give it a arrow function here, a callback, and in that callback, you can give it the set timeout. And then I can just have it resolve. Resolve just means when the promise finishes, make it be a successful promise. So resolve means resolve with successfully added fortune. Okay, so resolve just means, hey, the asynchronous code is done with its work. So it's successfully completed its work. That's what it means. Resolve means the asynchronous code here successfully completed its work. So if it did that, then we can do a dot then here. So random fortune middle, it's going to return back a promise. So we can do a dot then on here. Dot then we can run say bye. So now look at this. We are able to get it written in this order that we want it to run in. Resolve is not defined. I got an error. See, it says resolve is not defined. Why is that? Resolve is not defined in line 53. Right here, I forgot to give it the resolve and reject. And the reject is if something goes wrong, like if it wasn't able to do some lines of code, like maybe some line of code didn't work, then I would do a reject. We'll talk about reject later. That's going to be the dot catch. So if any error happens, what to do. So for example, let's say some error happens here. So if we can try this block of code. But if an error happens, we won't be able to resolve. We'll have to catch the error right here. And this is going to represent whatever error happens. So let's say our array doesn't even exist, like random fortune. What if it's not even an array? What if it's just like a number, right? If our random fortune is just a number, we should get some, yeah, it says undefined, right? So we don't want to do a resolve. We want to do a reject. Reject with the error. So let's, in this case, if there's an error, we would have a dot catch. And then whatever error happens, console.log, the error. So it'll show us our error message here. Whatever error happens, it should. So it's going to try this block of code. And it's going to do random fortune at this, at a certain index. But what if random fortune, yeah, let's just actually make it give an error. Okay. There we go. There's our error, right? But it still runs the next, the goodbyes. And maybe if there's an error, I wanted to paint to the DOM. The DOM is just this HTML that you see, the web page. Instead of trying to put the random fortune in this box, if there's an error, it will do an H4 tag. It'll also create an H4 tag. So let's do this. It'll create an H4 tag. And then it will add to the H4 tag, H4 tag.innerText. Some text saying, error, your array doesn't have anything. Okay. And then we can put that in the middle column. So to the middle column, append this H4 tag. So this is just some HTML I'm adding with this message. So if there's an error, it'll say error. Your error doesn't have anything. Your array doesn't have anything. So it's going to try this code. And if anything doesn't work perfectly, if there's any errors, it's going to actually hit the catch. And whatever error happens, it's going to reject with that error. But it'll also append this HTML right in this box saying this message, error, your array doesn't have anything. It'll put that here. Cool. In order for us to be able to see this, see the reject message, we can actually have a dot catch here. Whatever error message we get back, we can actually take a look at it. Oh, what is the error? Oh, this is the error that happened. So in this case, we can still run greet and then run random fortune middle, and it will run greet and it will run random fortune middle after. But if there's an error, it's not going to break the whole application. It's actually going to be caught. And we're also going to be able to run the say bye function. So we're able to dictate the flow of the execution of our code by using promises. So that's the benefit of using promises. And yeah, so there's some actual examples of promises where you're making an API call that I also want to talk about. So let's pause for that, and we're gonna talk about it now. Welcome back, everybody. Hope you had a nice little break, but there is no breaks because this is a solo recording. I got a break. What's up with you? So, all right, let's continue talking about what promises are. So when you have a promise, you can do .then and .catch on a promise, and if there's any errors, it'll hit the .catch. But if the promise successfully resolves, it'll hit the .then. So in this case, the promise, if it successfully resolves, it'll hit the .then. And what are we doing with this message? Well, you can do whatever you want with this message. It really depends. In some cases, whatever gets resolved, you might actually want to use that message at some point. So if you want to, let's say I wanted to log this message to the console, just so we can keep track of, a log of the events that are happening. If it successfully worked, or if there was an error, maybe I'll have it say some message here as well. So, okay, so let's do that. So in the greet function call, it's going to return back to us a promise that resolves. So that means we can actually do a .then on it. And this message that gets resolved, we can actually use that information somewhere. So here's the .then on the greet. But if I just have this function passed into the .then, it's going to just run this function and return the value of this function call, random fortune middle. So it's going to run this function, and then it's going to give you back whatever this function returns, which is a promise. It returns a promise. And to that, I can do a .then again and say bye or something, right? But another way to write this is I can actually write it in this syntax with the arrow function syntax and put curly braces here. So now this function is not returning random fortune middle. So we actually get some error here. The random fortune middle is actually not running, right? So I can tell it to run random fortune middle. So this is another way of writing it. And I can return yep, there we go. So I can actually return this value right here. And right now, our random fortune is not working because we actually have an error. Your array doesn't have anything. But that's because, let's take a look at our flow. It's running the greet, and greet is successfully resolving. It's returning a new promise that's going to resolve with this message, completed the greetings. So whatever message that the greet resolved with, if it resolved, it's going to hit the .then, and the content that it resolved with, I can extract it right here in this inside of this parentheses as a parameter. Let's call this a greet log, I don't know, greet message. And I can console.log that here. Greet resolved message. So now I can see after greeting is resolved, it says completed the greetings, right? I can see the resolved message, which is greet resolved message. So here's the resolved message, completed the greetings. I can see that there. And similarly, here inside of this .then, I'm returning a function call. So this function call is going to run. So right here, get random fortune middle is going to run. And it's going to, if this array, if this is not found, or if there's some error with this array, it's going to try to get a random value from that array. But if it can't get a random value from random fortune array, it's going to hit the .catch, right? So let's actually turn this back into an array of random fortunes. And where is my random fortune code? Right here. Copy that and paste it. So there it is. Okay. Let's make that random fortune. Okay, so what's going to happen is it's going to run get random fortune, and it's going to return back a promise. And in this case, it's going to resolve because it was successfully able to get a random fortune because this random fortune variable exists with an array. And it's going to resolve with this message, successfully added fortune. So that message, since I'm returning this, we can actually extract it in the dot then, because this is returning a promise that is going to be resolving, right? Because it's able to successfully get a fortune, so it resolves with this message. So if it resolves, it's going to hit this dot then, and we can actually extract that message by putting an arrow function here. And let's just call this random fortune resolve message. You can name this anything you want, by the way. I'm just naming it something descriptive. And I can console.log random fortune resolve message. And I can tell it to run say bye. So let's see what happens. Complete the greetings. Perfect. In random fortune function, successfully added fortune. That's the resolved message, successfully added fortune. So this resolved message, we were able to extract it in the dot then, because whatever is resolved from this return of random fortune middle, and random fortune middle is resolving a message right now. So it's going to hit the dot then, and whatever was resolved from this function call is going to be right here. And I was able to console.log that, successfully added fortune. And then there's the say bye function is going to be run here. So I was able to get this code to run in an order that I wanted it to run, because it has asynchronous code in it. And with asynchronous code, you have to kind of force it to run in a certain order. Otherwise, it's just going to run in the order that it's completing it. For example, this one's going to take 2000 milliseconds. This one's going to take 1000. This one's going to take 1000 milliseconds. So these two would run quicker if we didn't have either callback hell or if we didn't have promises. And promises, no matter how many functions you have attached to one another, you can layer your promises just one layer deep. You see how my tab is just one layer? But with the callback hell, if you have 3 functions, you're going to have 3 layers. If you have 20 functions that are relying on one another to execute, and they're all asynchronous functions, then you're going to have 20. Imagine indenting this another 20 times. Like another function. Funcation. Okay, right? And then if you keep doing this, another again, right? So this is going to look a little bit hard to read and hard to follow, and this is what's called callback hell. But this is much better to write. So let's switch gears and let's actually make an API call to get some cryptocurrency coins. Okay. So we actually have an API called CoinGecko. Here's a API endpoint. I'll put this endpoint in the code here, and I'll actually be pushing this to GitHub, and I'll share that in the description. So please like and subscribe. So you will be able to have all this code as you need it. So let's say we have in this application, yeah, we want the greetings, random fortune, and goodbyes to kind of happen one after the other. But we also want some other code that doesn't rely on the top row. Maybe the top row can complete however long it needs to take to complete, but the bottom row is going to also have its own process that's relying on each other, but not on the top row. So the bottom row, maybe here, I'll get a list of all the cryptocurrency coins and their prices. And then here, I will just get the information about the cryptocurrency that had the largest percentage gain in the past 24 hours. But I'll first show all of the coins and then have it show the most profitable coin in the past 24 hours. So we can do that. We can have a function here. Let's call this function get all coins. And this function is going to make an API call. So in order to make an API call, I have actually, in my HTML, I have imported Axios. If you're only using Node and you're just doing backend programming, you can actually npm install Axios, and you can import it like this by saying const Axios equals to require Axios. And what is Axios? Axios allows you to make API calls using JavaScript and get back responses from APIs. But if you do it this way, when you have your HTML file attached to your JavaScript file, you're basically running JavaScript on the browser instead of in your terminal. In using Node, instead of using Node on your local machine, you're using in your local machine, you're using the browser's JavaScript console. So in this case, you can't use it. You can't import Axios this way. I know my students at at the coding bootcamp that I teach at, they are currently using backend. So you guys are probably going to use this way. But in this particular demo, since this is attached to an HTML file, you have to import Axios like this. So this is me importing Axios. Perfect. Okay. So here now I already have Axios available. I can do something like this. Let me just console.log in get all coins function, just so we can have a log of what code is running. And then in the get all coins, we're going to make an API call, to CoinGecko API to get all the coins. So before I even do that, let's just take a look at what the CoinGecko API gives us. It gives us back an array of objects. Oh, oops, wrong button. It gives us back an array of objects. So each object is a cryptocurrency coin, and it's already ordered by market cap. So it has the most popular coins at the top. But just because they're the most popular doesn't mean they're the most profitable in the past 24 hours, right? So, but these are the pieces of information each coin object has. So we're going to get back an array of coin objects, and each coin object has an ID, symbol, name, image, current price, market cap. And one thing that we might look at is total price change percentage in the 24 hours. So which one has the highest price change percentage? Which one actually made the most profit in the past 24 hours? So we're going to look at that in just a little bit. But for now, what if with this array of objects, I wanted to just populate all the coins and their prices here? So let me even write that down here for this div. For this div called left, it has an ID called all coins. I gave it an ID. Well, don't worry too much about the HTML here, but just know that I can type in some words here saying all crypto coins, and then here it is. It says all crypto coins. And then I'm going to use my JavaScript to populate this HTML at this particular div. A div is, just think of this box. This box is a div right here, okay? So in this box, and I gave it a name called all coins, not altcoins. It's not alt season yet, but all coins. So in this box with the name of all coins, I want to give it a bunch of content. Okay, so let's do that. We're going to make an API call, axios.get. So this is how you make a request to get data from an API. It's axios.get. And then I would put the URL of the API. This is called the API endpoint. I would put that right here inside of a string like this, and then option Z to word wrap it. Cool. So this code right here is actually asynchronous, meaning it takes an unknown amount of time for it to run. We don't know how long it could take because this is an API call to an external API hosted by CoinGecko's servers. So it's some other server. This server is not even in my computer. Matter of fact, in order to get data back from this API, it has to travel through the internet to someone else's server, to someone else's application, get back the information, and come back through the internet into my device. And that actually takes like a couple milliseconds, not that much time, because we live in 2022. So that's pretty cool. But nonetheless, we don't know how many milliseconds. We don't know if it's going to be 1 millisecond, 10 milliseconds, 30 milliseconds, even 1,000 milliseconds. If it's really slow, that means it took like a whole second, right? That's slow now, right? So we don't know how long this is going to take to run. So this actually gives us back a promise. So in order to actually get information from a promise, we need to use dot then in order to get information back from the promise if it's fulfilled. If this API for some reason doesn't work, like let's say I misspell it, right? There is an error. CoinGecko. Oh wow, it thinks like I'm trying to get hacked, honestly. But okay, in this case, it would not work. That would be a dot catch. So you need a dot then and a dot catch, and the dot then is the data that if it successfully comes back, all this data. So let's just say the response from the API. If I were to console.log the response, let's just see what the response looks like. So I need to call, and let's say I want to get all the coins, regardless of how long it takes to do the greeting and the random fortune and the goodbye part. I want it to not be involved in this chain of events. It's going to be its own chain of events. So I'm going to say get all coins. And when I call get all coins, let's just see what happens. Okay, so it says get all coins. In the get all coins function, here's my data. So it's an object. This is the response that I get. This response is the whole object. And of this response, I don't want all this stuff. I just want the data, which is this array of coins. So I just want these cryptocurrency coins. So whatever response I get back, I want response.data. Let's just do console.log it for now. And there's our response.data. This is our 100 cryptocurrency coins. And notice, actually, even though I told it to run the greet function first, what ran first? It ran the in get all coins function first, because even though it's written after this whole sequence, remember, this is asynchronous code. So while we're waiting for this process to run, we can be efficient and have also get our cryptocurrency coins while it's doing the whole greeting and random fortune and then the goodbye part. We can say, yeah, you can do that, but we're not going to wait for you. We're going to make sure we get our coins and populate the bottom row. Maybe it's a race between the top row and the bottom row to see who loads up first, right? And in this case, the bottom row looks like it's winning because we got the get all coins running and it's getting us all the coins. So the API is actually quicker than these functions because these functions take like 2000 milliseconds. That's 2 seconds, 1000 milliseconds, another 1000 milliseconds. So those functions take a while. So yeah, we can go ahead and run get all coins. And here's our data. So in order to get the actual data, you have to do response.data. Otherwise, it gives you a bunch of other information that we don't really need. If I just have response, it gives me data, which is the array of 100 coins, but also status text, headers, some other data that for this demonstration, we don't need. For other demonstrations, we might need it in the future, but not for this one. So we just want the data. Another way to write this, though, is I can actually destructure from the response the data keyword by writing it like this. Well, you need parentheses if you're going to do that. And then you need inside the parentheses, use curly braces and whatever you want to destructure, data. And now I can just say data, console.log data. Now I don't have to type response dot. That's the cool thing. But I can also destructure other properties, like not just data, but anything else that we saw in the response, like status. There was status there, right? And I can also say data, status. So now there's a 200 for the status. 200 means it was a successful request. Cool. So there's our data. And what do we want to do with the data? Well, maybe we want, once we get all the coins, we wanted to run something else. So what we can do is, let's say this data, we're just going to return the data because that's the information that we really want to use. And in the dot catch, this is if like the API doesn't work. For example, let's say I misspell something here. I get an error, right? Because the API doesn't work because this endpoint is wrong, or maybe their server is down. So there's some error. If that's the case, I need to do something with the dot catch. So if there's any error, whatever error we just saw right here, uncaught, in promise, message, request failed, right? This whole error message, we can catch it right here. And this word represents that error message. And we can just console.log error and then maybe return error dot message. And then we can just console.log the error dot message too. There you go. Response failed with the status code of 404. What did I delete from this? CoinGecko API v3. v3. Okay, so that should make it work again. Let's make the API work again. Okay, cool. And it's not logging our all coins anymore because I just told it to return the coins. I'm not telling it to log it yet. So what we can do though, instead of logging it to the console, maybe we can tell it to do something with that data. For example, when I call get all coins, it's returning back. Well, let's see what it returns back. Console.log, what does this function return back? Console.log, the value of this function call. Undefined. Because right now this function call is not actually returning anything. I need to return. This is just like returning a promise that it could resolve or it could reject. Just like here, where I'm returning a promise. In this case, I forced it to be a promise. Here, an Axios call is already going to give you back a promise. And you can do .then. So whatever response I get back, maybe I wanted to just only return back the data from that response. But if there's any errors, maybe I wanted to return the error message. Okay, cool. So get all coins, it's an asynchronous function because it has asynchronous code inside of it. So what we can do now, if I save this, it says promise pending. It's a pending promise. So get all coins is a pending promise, meaning we are waiting for it to resolve. So whenever it finishes, we can do a .then. So what do we want to do once we get all the coins? So inside of this .then, we can actually put in a callback function. And don't worry, we don't have to do nested callbacks deeper than one level because we're using this .then syntax, which is great, compared to callback hell, which is not so great. So in this .then, inside of this parameter for the arrow function, whatever word I put here, this word will represent whatever this function call returns, like whatever this resolves, whatever this function call resolves. Since we're using a .then, it represents whatever this function call resolves. And in this case, it resolves in the .then, whatever, when it does get back a response, when it gets back a response from the API, the CoinGecko API, we're getting that data, which is the array of coins. Response.data is going to be this array of coins. So returning that back. So this is basically what's going to be here. So if I console.log whatever I put here, you'll actually see that array of coins, right? There we go. So this is whatever I put here. And let's name it something more descriptive. Let's call this coins. Okay, so there's our coins. But I want to do something with these coins. I want to maybe put those coins on the page. I want to paint the page with those coin objects. So I could have all that code here, or I could be more organized and I could have a function that's going to accept a bunch of coins. Let's do that. Let's create a function. Function paint coins to window. And it's going to accept an array of coins. It's expecting it to be an array, just like this array of coins right here that we see on the browser, on the console here. Because what we're going to do is we're actually going to pass this to this function. Okay. So this coins that we get back when we retrieve all the coins from the API, once we retrieve that data, then we can actually work with it. We can't work with it until we get that data, right? So we have to have this .then, meaning we'll only try to put the coins on the HTML once we get the data from the API. So once we get the data from the API, get all coins, right? Get all coins is gonna return back all this, which is an Axios call that's gonna get us back the data, the data from the API. So that data is we're gonna label it with the word coins. We can pass that coins, which is the array of objects, to the paint coins to window function. Paint coins to window with coins. And right now the paint coins to window function is not doing anything. But what we can do, let's get rid of the console.log. We can console.log it here just to see if it's actually getting to this function. So let's see if the console.log happens now. I don't have the console.log here. I have it in here, but it looks like paint coins to window function is able to log the coins. Let me even console.log in paint coins to window function. So in get all coins, once it gets all coins, it goes to in paint coins to window function, and it's going to log the coins. There it is. And what do we want to do with the coins? Well, for each coin, I'm going to write this in English, and then we'll talk about what we want to do. Create an ordered list element in HTML. An ordered list is just something where you can do the 1, 2, 3, 4, 5, 6. It's basically this, something like this. So what if I want an ordered list of the coins? Or I could create an unordered. Unordered would be if it was bullets. ELEMEN elements in HTML. And then for each coin object, create an LI element. So an LI element, so you can think of an ordered list. Let's take a look at this right now. This is an ordered list, right? What does an ordered list look like? It's going to be in the OL tag. The OL tag allows me to put a bunch of sections here. So notice the OL is this whole highlighted part. You see the highlighted part at the top right here? You'll see some highlighted part. That's the OL, which is the whole section of the numbered items. And then each LI is a numbered item. So I want to create one OL, and I want to create an LI for each coin object. So let's do that. Let's get rid of this console.log. And then for each coin object, create an LI element. And give that LI element information about the coin name and price. Okay, so let's do that. And then add the unordered list, or attach the unordered list to the HTML. So what we want to do is we want to create this ordered or unordered list with a bunch of items, a bunch of bullets of each coin. And then once that's done, we want to attach that thing to the page, to this div right here, to this particular box. So let's do that. Create an unordered list in HTML. Documents.create elements. This is how you create an unordered list in HTML. We can tell it OL for an ordered list or UL for unordered list. And let's put it in a variable. Let's call this let unordered list equal to this. And then for each coin object, I'm going to create an LI, because remember, coins is going to be an array of coin objects. So I can use this loop saying coins.for each coin object. So this word coin object, what does that look like? Console.log. And I can name this word anything I want, but whatever I name it, let's see what that looks like on the console. Look, it looks like each of the coin objects. So coin object dots, and I have all these properties that I can use. Dot name, dot where's the price though? Dot current price. Okay, so I can do coin object dot name and coin object dot current price. So now I just get all the coin objects and their names and the current price. But I want to put all this information, instead of console.logging it to the console, I want to actually put it inside of my ordered list or unordered list. And in order to put things inside of an unordered list, I need to give it a bullet to put into the whole list. This is the whole unordered list. And for each coin, I want to create a bullet. A bullet is going to be an LI. So let's bullet item is equal to document.create elements LI. This is going to create an LI for each coin object, and we're going to name it bullet item. So for each coin object, create an LI element. We did that. Give LI elements information about the coin name and price. So instead of console.logging the coin name and price, I can say bullet item dot inner text is equal to, and I can give it a string with the coin object name and price. $ curly brace, coin object dot name, and then maybe like a dash just to separate it, and then $ curly brace, coin object dot price. Okay, cool. Now, just because we put the coin object dot name and coin object dot price inside of the bulleted item, well, we need to put the bullet item inside of the unordered list. So unordered list dot append child bullet item. And don't worry if you don't know too much about what I'm doing with the HTML, adding things to the page, but basically what I'm doing is I'm just getting each coin object and putting it in some HTML tags and putting that HTML tag into my HTML. And where do I want to, where in my HTML do I want to put it? I want to put it in this box called all coins, which is going to be this box where it says all crypto coins. I gave it the ID of all coins. So I can tell it to attach this unordered list to documents dot get query selector hashtag all coins. So this is going to select that div that has the ID of all coins, because I'm telling it ID using hashtag. Hashtag means ID of all coins. So select that portion of the page, and to that append means attach this unordered list that has a bunch of bullets now. Unordered list. So cool. Notice I have, take a look. It looks like the API is faster than these other functions that take, 2 whole seconds to run, or 1 whole second to run, or another 1 whole second to run, right? Notice that the API is faster. Why is it undefined for price? Coin object dot price. It's not dot price, it is dot current underscore price. Okay. And maybe I want a $sign in front of them. I know there's already a $sign here, but that's just to put a variable. So let's put another $sign just to say, hey, we're talking about dollar bills, y'all. Okay, cool. Dollar bills, y'all. Just wanted to say that. But okay, so here we go. We got this information. And what if, as soon as it loads up all the coins, then I wanted to, I wanted to do something else, but I don't want it to do something else with this last box until all the coins are loaded. We can do that. We can tell it to do that. Now, another way to write this dot then is, since I'm going to tell it in the dot then, like once I get all the coins, then with all the coins, like once I get all the coins, the data of all the coins, that's from the API call, that data is going to be this coins. With that array of coins, call the paint coins to window function, which is going to actually put it on the HTML. That array of objects, we're going to actually paint it to the HTML. That's what we're doing with this function. Well, what if I wanted to write it in a different way? Since you're writing it this way, another way to write it is, you can just say dot then paint coins to window. This is doing the same thing. If you just tell it dot then and then a function name without calling the function like this, if you just give it the name of function, it's actually going to call this function and return this function. And it's going to call this function with whatever the dot then receives. And the dot then, what is the dot then receiving? It's receiving whatever this function call is resolving. So get all coins is resolving the array of coins. So that array of coins is going to be passed to this function call. So it's going to, basically it looks like this. It looks like this part right here. It's the same thing as this. This is another way to write it. And since we're actually, no, not quite. This is the other way. This is basically the same now. Not basically, this is exactly the same. Now that those are the same, we can actually just get rid of one of them. So this is the same syntax. Not syntax, this is the same concept, different syntax. Cool. And let's say once that's done, maybe it can return. In order for me to do something after this is done, but only after this function finishes executing, what I can do, can you guess what I can give back from this function so that I can do dot then again? If you guessed promise, then you're right. I can say return new promise or new. I can just return. Another way to return the promise is just I can say return promise dot resolve completed painting the page with the coins, with all the coins. So I can tell it to resolve with this message. So this function paint coins to window, it's actually returning back a resolve promise. So after this dot then, I can actually do dot then again. And inside of here, I can give it a callback function in a word as a parameter. I can name this anything I want, right? Whatever I name it, it's going to actually store whatever this dot then resolves. And this dot then returns back the paint coins to window. It might help if I write it this way instead. Just know that this is the same thing. So it's going to return this function call. And so when this function gets called, it's going to paint the page with all the coins that was given to this function. And then it's going to return back a promise.resolve. So since this returns back a promise.resolve, I can do a dot then, and whatever this resolved, that's going to be stored in the word anything. So this message right here, it's going to be right here. It's going to represent anything. If I were to console.log, you should see completed painting the page with all the coins, right? There's that resolve message. There it is. Okay. Cool. So what do we want to do next? Well, maybe we want to make another call. Maybe we want to make an Axios call. Or maybe we want to get a coin that has the largest price change percentage in the past 24 hours. So let's have a function that's going to do that for us. It's going to get back an array of coins. And it's going to, instead of resolving this message, maybe it's going to resolve with that array of coins. So now anything represents that array of coins. Let's take a look. There it is. Anything represents the array of coins. And instead of just console.logging it, what if I wanted to pass it to another function so that it can sort the array of coins? By their 24-hour price change percentage. So let's say I want to get the most profitable coins in the past 24 hours. So I could do that. I could actually just do it right here too, or I could have a function here. Let's just do it right here. Coins.sort, and for sort, you need to give it two parameters, coin A, coin B, return coin. If I want it descending, so largest to highest, I will do B minus A. coin B dot, what does each coin have again? Price change percentage 24 hours. So this property minus coin A dot that. And then console.log coins. Let's see if it shows the coins in order now. Okay, let's see. No, it's still in the same order. Coins.sort. Sorted coins. Oh, you know what? I said rice change percentage. That's why. Price change percentage. Okay, there we go. Okay, this should be in order. Okay, so Clay token was the most profitable in the past 24 hours. What was this percentage change? 11%. Wow. So it went up 11%. Okay, cool. So this coin was the best coin so far. And then some other ones like Kava. I eat Kava for dinner, but here's price change 4%, right? So now I have it ordered by the most price change to the least. And maybe I just want the first coin. I just want to find, I want to give back coins at index 0. This is going to give me the most profitable coin only. So Clay token. And what if with this most profitable coin, I wanted to make another Axios call that just gets me information about that coin? Because there's actually another API endpoint very similar to this, which will give me more details about just one coin. If I go to coingecko.com/coins and give it an ID of a coin, for example, what is the ID of this coin? Clay token, Clay-token. Clay-token. I get information just about Clay token and a bunch of extra stuff about Clay token, like even like description. So I get even more details about a specific coin from this API endpoint. So let's say I wanted to make a call to just get information about one API or one coin. So let's have another function, get one coin details. And it's going to accept a coin object. And with that coin object, remember with that coin object, we use the coin object.id to make an API call to this coin object.id is going to be right here. So we want to make an API call, Axios.get to something like this, except this could vary because what if tomorrow something else is a top performing coin? So let's just make this into a dynamic string where I can do $ curly brace, coin object.id. So whatever coin object ID I want to search up, it's going to give me information about that coin object's ID. So I can actually return an Axios call. And maybe with this Axios call, I want to format the data. .then response, return response .data. Another way to write this is I can write it in one-liner. So whatever response we get back, give me back just the response.data, because the whole response, as we saw earlier in the video, has too much stuff that we don't need right now. We just want the .data part of the response. So here's a function that's going to return back a promise for us. So get one coin details, but it needs a coin object to get us information about that coin object. So that coin object is coins at index 0. So let's call this a let top performing coin past 24 hours is equal to coins at index 0. This is a crazy variable name, but okay. So now I can actually call the get one coin details function, and pass in the top performing coin in the past 24 hours. So what I'm going to do here is I'm calling this function get one coin details, and it's just going to make an Axios call to just get details about one coin, not like this API where it gives me information about all the coins. But we're going to make a request to this API where it just needs the ID of the coin, and it'll give me even extra details about that coin. So that's what this function is doing. So I'm calling that function here. And if I return it, then I'm actually returning what this function call gives back and resolves, which is this response.data. So I can actually access that in this dot then right here. Let's call this popular coin details. Why am I calling it popular coin details? Because response.data is basically going to be right here. And response.data is the data related to the popular coin, which is basically all this stuff that you see that you see scrolling right here. That's information just about Clay token or whatever coin happens to be the most popular coin in the past 24 hours. So that particular set of details with this details, maybe I want to update my page with that information. Very similar to the function here, paint coins to window function. Maybe I'll have a paint one coin detail to window, and it's going to accept a coin object, or it's going to accept some coin details. And then for that coin details, it's going to well, we need a place to put that information. Let's give this div, this last div, I'm going to give it a name using ID is equal to coin detail. So I want to put it inside of this div, and it'll be something like that. It'll be like a H3 maybe. It'll just say most popular coin is, and then coin name here. It'll look something like this, but it'll wait for this to finish and then it'll show that information. So I'll have it populate here, but in order to populate here, I need to give this area an ID so I can tell the JavaScript where to put my information. So wherever the ID is equal to coin detail. So document.query selector hashtag coin details. So I'm telling it, hey, select that part of the document of the HTML page, and let's call this let's call this div. I don't know. We can call this div or coin detail div. And to that div, I'm going to want to create a element, maybe like a paragraph tag. Let p tag, paragraph tag is equal to document dot create element, and this is going to create a paragraph tag, and to that paragraph tag I'm going to add some content from coin details, and the coin details is going to look like this. So maybe the coin details dot name and then dot description dot in English. So coin details dot name and description in English, and maybe I also want its current price in US dollars. Okay, so let's do p tag dot inner text is equal to, and let's put all that information. $ curly brace coin details dot name, and let's just say name is this. Awesome. And then maybe it'll also say the description. Let's do a /n for new line. Description is going to be coin objects or coin details dot description.en for the English. So coin details dot description.en. And then let's do another line break. /n, and then current price is going to be market data dot current price, and then I got to do dot US dollars USD, because if I just do market data dot current price, I get back this whole object, and to that object I need to do dot USD. So let's say let's actually put the current price here. $sign curly brace. Coin details dot, what do we say? Market data dot current price dot USD. Okay, cool. Okay, cool. So to that paragraph tag, add all these details to that paragraph tag. And then now, just because we did that doesn't mean it's gonna run. We need to also tell it to actually add this paragraph tag to the div. So can attach this paragraph tag to that div, which is this div right here. So coin detail div dot append child p tag. So let's see what happens. Oh, nothing happens yet because I haven't told this function to run yet. So here, once we, so what we're doing is we're getting all the coins, and whenever we get all the coin data, we're going to paint the page with all the coins. So it's going to paint the page with all the coins. And this painting the page function with all the coins, that's actually going to give me back a resolved promise as well with all those coins again. So then I can get all those coins again, and with those coins I can sort them by which one is most profitable in the past 24 hours. And the most profitable one will be at the top. It'll be at index 0. So I'm just going to put that in a variable. So this will be the most profitable coin. And I want to get details about the most profitable coin. So it's going to call this function, get one coin details about the most profitable coin. And that information is going to be coming from the API call. And it's going to give us back the response.data. But remember, it's giving us back an Axios call. So this is a promise. So in order to extract what this promise returns, which is the data about the most profitable coin, I need to do .then. And this represents that data about the most profitable coin. And with that data, I want to paint the page with that data. PAINT, paint. So I can tell it to paint with the popular coin details. So there we go. Name is this, and the description is this. Cool. So notice how it has to wait for this to come before this comes. Matter of fact, let me do an incognito window, because right now all this is cached. So let's just go to an incognito window like so, new incognito window. And if I paste that, notice, take some time here. What's going on here? Inspect console. It's actually taking a little bit extra time than it needs to. Okay, there it is. Notice, I don't know if you noticed it, but you might need to pause and rewind the video, but this loaded up a little bit quicker than this one, like a microsecond. And that's it. That's it for promises and why it's useful. Awesome. In another series, we're going to talk about the async await syntax and why, what is that syntax and how we can build this using that syntax. Thank you for joining us, and take care. Peace, love, and namaste.